Have you ever stopped to think about how some of the simplest things around us can pull off what feels like actual magic? Well, today, we're going to pull back that curtain. We're going to look at the simple, beautiful physics that helps us see our world, sometimes more clearly and sometimes, well, a little differently.
I mean, really think about it for a second. The side view mirror on your car, right? It shows you this huge panoramic view, but it has that little warning, objects in mirror are closer than they appear. Then you've got a pair of eyeglasses, which can take a completely blurry world and just snap it into sharp focus. One tricks your eyes, the other one fixes them. What is going on there?
You'd think it would be something incredibly complicated, but the truth is, it all boils down to just two simple rules that light pretty much always follows. And once you get these two ideas, all of these optical tricks start to make perfect sense. So, let's get into it.
All right, so here they are, the two fundamental behaviors of light that make everything from a simple mirror to the Hubble Space Telescope possible. We're just going to call them bouncing and bending. Now, the fancy terms are reflection and refraction, but bouncing and bending works just fine for us.
Okay, first up, bouncing or reflection. This one is so intuitive. Imagine you throw a tennis ball straight at a smooth wall. It bounces right back, right? Well, light does the exact same thing. When it hits a shiny surface, like a mirror, it just bounces off in a super predictable way.
And rule number 2 is bending or refraction, and I guarantee you have seen this 1,000 times. You stick a straw in a glass of water, and it looks like it's broken right at the surface. That's refraction. It happens because light actually changes speed when it moves from one thing to another, like from air into water. And when it slows down or speeds up, it bends.
And that's really it. That's the whole secret. Light either bounces off stuff or it bends when it goes through stuff. Every single optical tool we have is just a clever way of manipulating one of those two things.
So, let's put that first rule to the test. Let's talk about bouncing. It's time to solve our first mystery, your car's side view mirror. Why on earth does it show you so much but get the distance all wrong?
The secret isn't just that it's a mirror, it's the shape of the mirror. It's a convex mirror, which is just a fancy way of saying it curves outward. It bulges towards you. And that one simple curve is what makes the whole magic trick work. It forces all the light that hits it to bounce away from each other, to spread out.
Okay, so here's how it messes with your brain. Light from a really wide area, like cars in the lane next to you, hits that curve. The mirror then bounces all those light rays outward, spraying them so they can all fit into your eye. Now, your brain assumes light always travels in a perfectly straight line, so it traces those spreading rays back to a point behind the mirror where they would have met. The result? You see a smaller, wider version of reality.
And there you have it. It's a trade-off. The mirror makes things look smaller and farther away on purpose because in exchange you get a much wider field of view. It gets rid of those dangerous blind spots. So that warning label is there because the mirror is choosing safety over accuracy. Case closed.
Okay, so we've seen how bouncing light can, trick our eyes for a good reason. But now let's see how bending light can fix them. It's time for our second case file, eyeglasses, and how they use refraction to make things clear.
So what exactly is a lens? Well, you can think of it as just a carefully shaped piece of something clear, glass, plastic, whatever. Its entire job, its whole purpose in life, is to hijack that bending rule, refraction, and bend light in a very, very specific way. And just like with mirrors, the shape is everything. Lenses pretty much come in two main flavors. You've got convex lenses, which bulge out and pull light rays together, making them converge, and you have concave lenses, which curve inward, spreading the light rays apart, making them diverge. Which one you need all depends on what your eye is doing wrong.
So if you wear glasses, you've probably seen a number like this on your prescription before. And it looks pretty technical, doesn't it? But what does it actually mean? Turns out it's just a simple measurement.
That letter D there stands for diopter. And a diopter is just the unit we use to measure a lens's bending power. That's all it is. The bigger the number, the more that lens bends light. It's just a score for how strong the lens is.
And with that, mystery solved. If your eye isn't focusing light perfectly on your retina, maybe it's focusing a little too soon or a little too late, the world looks blurry. An eyeglass lens is shaped just right to give the light the exact amount of pre-bending it needs so that by the time it gets through your eye's own lens, it lands perfectly on the retina. Bam! Sharp, clear vision.
So what this all really means is something pretty profound. By just understanding these two simple rules,
We're not just passive observers anymore. We can actually become the architects of our own perception. We can design how we see.
So, let's just recap the big ideas here. It's simple, right? Light has two rules. It bounces and it bends. The whole game is just using curved surfaces to control exactly how it bounces or bends. Mirrors use bouncing to expand our view, and lenses use bending to correct our view.
When you think about it, this knowledge is it's incredibly powerful. It's the foundation for literally everything, from the glasses on your face, to the camera in your phone, to the gigantic telescopes that let us peek across the cosmos. We learn to control a basic force of nature to literally extend the power of our own senses.
And that kind of leaves us with a pretty mind-bending thought, doesn't it? We've become masters at engineering light to completely change our sense of sight. So it really makes you wonder, what other parts of our reality, of our perception, could we start to reshape if we just took the time to understand their fundamental rules? Thanks for joining me.